Section 5.4, factoring and solving polynomial equations. First, I'm going to review what we talked about in Chapter 4, which was the chapter all about quadratics, when you learned how to factor and solve quadratic expressions. And you learned how to factor the following types. When you had a squared term, an x term, and a constant, you used what we called reverse FOIL. And if the leading coefficient was anything but 1, here we have a 2, remember we used that little method where you multiply the first and the last number, and here we get negative 24. So we're looking for factors of negative 24 that somehow will get negative 5. In this case, if we have negative 8 plus a 3, that will get us negative 5, and if we multiply those two numbers, we get negative 24. So those two work. We rewrote it as 2x squared minus 8x plus 3x minus 12. I'm going to go through this kind of quick, just review. And then we grouped the first two and the last two, pulled out what was in common. Here we can pull out a 2x, and we're left with x minus 4, and here we can just pull out a 3, and we're left with x minus 4. So our two binomials are 2x plus 3 times x minus 4. So that was the one method. If we looked at the difference of two squares, if we had the difference, so subtraction, of two squares, we have 9 and 4, which are both perfect squares, and there's no x term, we can just write our two binomials using the roots of 4 and 9. So the root of 4 would be 2, so we write 2x in both parentheses. Since we have a minus here, we're going to have opposite signs, so a minus and a plus, and then the root of 9 would be 3. And the last we learned was if we have a common monomial, here we have 6x squared plus 15x, we can pull out a 3x, and we're left with 2x plus 5. So in this section, we're going to use those properties that we learned in Chapter 4, and we're going to kind of build upon them to factor polynomials that have a degree greater than 2. So first, let's look at some polynomials that have some patterns that will help us factor. Let's look at the sum of 2 cubes first. And that just says we have something cubed plus something cubed. And if we have that, this is the nice little formula we're going to use to factor. So let's look at a specific example. If we have x cubed plus 8, this is our a cubed plus our b cubed. And let's label what a and b are, because that'll help us when we get down to the factoring part. Our a in this case is x, because a cubed, x cubed, our a is this x right here. So let's look at b. You might be saying, Miss Fegan, you're crazy. This is nothing cubed, it's just the number 8. Well, think about, remember, something cubed is a number times itself 3 times. So what number times itself 3 times would give us 8? And I hope when you're thinking, you think of, oh hey, 2. 2 cubed, 2 times 2 times 2 equals 8. So this could be rewritten as x cubed plus 2 cubed, and that's the same thing because 2 cubed is 8. So now we can use this nifty little formula and factor. So the formula says we use a plus b is our first binomial. A, in our case we already said was x plus b, which we said was 2. So that's how we have x plus 2 right here. And then just follow the formula for the second part. A squared, our a is x, so x squared. Formula says minus, so we put a minus. A times b, a being x and b being 2, so we have 2x plus b squared, and our b is 2. Remember, 2, not 8, so 2 squared is 4. And that is that polynomial factored. Looking at the next pattern, we have the difference of 2 cubes. Really the same thing, except there's some sign differences. Here you're going to be minusing because it's the difference. So the change in the formula is this becomes a minus sign, and this above was minus, and that becomes plus now, but really the same process. So if we label a and b, if that helps, a cubed minus b cubed. Here a is x, and b, you need to think of what number cubed gives you 125, and it's actually 5, because 5 cubed is 125. So if we rewrote it like that, that would be the same thing. And again, just fill in your formula and you'll get that answer. I'm going to do one more example of factoring the difference of 2 cubes, but one that's a little bit different. It has one more step at the beginning. If we look at this example, we see that we have our first term is to the power of 5 and this one is squared, so we don't have the difference of 2 cubes. But we can manipulate it so that it looks like that, so we can use our pattern that we just learned. Think about what you can take out that's in common. We have 16x to the 5th minus 250x squared. We can actually factor out right away a 2x squared, and that leaves us with 8x cubed minus 125. And we can check if these are a difference of 2 cubes. Well, 8x cubed, that is cubed, and we know from previous example that we can rewrite 8 as 2 cubed. So yes, and also we learned that 125 can be written as 5 cubed. So this is the difference of 2 cubes, so we can use this formula like we did above. And this monomial out here is just going to hang out until the end. We're going to use the pattern just for this part because this is the difference of our 2 cubes. If it helps, if you want to label A as 2x and B as 5, if that helps, go ahead and do that, because 2x cubed gives us 8x cubed and 5 cubed gives us 125. So then, fill in the formula, leave your 2x squared out front, and then fill out your formula. So we have A minus B, so 2x minus 5, times A squared, I'm just looking at this formula right up here, A squared, 2x squared, plus A times B, so 10x, plus B squared, which 5 squared is 25. So that is your final answer because none of these can be factored down anymore. So let's look at factoring by grouping. If you're looking at a polynomial and it looks like you can factor something out of 2 of the terms but not all of them, this is a good trick to use. So if we look, we can see that we can pull out an x squared out of these first 2, and then what we're left with is x minus 2. And here in these second 2 terms, we see that there's a 9 in common, but our goal is to also make this x positive, so go ahead and pull out this negative as well. So we're going to pull out a negative 9, which leaves us x minus, because if we pull out a negative, that sign changes, 2. So our 2 factors are going to be the 2 numbers that you factored out, so x squared minus 9, and whatever this factor is, which it should be the same when you're done. And we're not quite done yet because if you look closely, this is the difference of 2 squares, so this can be factored even more. You're not done until you cannot factor anymore. This can be factored out to x minus 3, x plus 3, and then x plus 2. So this would be your final answer. Let's do one more example that looks a little bit more complicated, but really we're using the same steps. Our goal is to get things that cannot be factored down any farther. Again, here if we look, we can factor out an x squared, but we can't do that to the whole thing. So this is a good place to use our grouping. So let's group the first 2 together and our last 2 together, and then pull out what's in common. So this first one here, we just said that it looks like we can pull an x squared, and we have left y squared minus 3. Here, this negative, we want to pull that out. So pull out that negative, and then it looks like also a 4 is in common. So you're left with y squared. Since we pulled out the negative, this turns to minus 3. And again, these should be the same when you're done, if you've done it correctly. So then our 2 binomials are going to be x squared minus 4, these numbers that you factored out at first, and then whatever these 2 binomials are. So y squared minus 3. And again, we don't have our answer until we cannot factor anymore. If you looked here, this is a difference of squares, so that can be factored more, and that can be written as x plus 2, x minus 2. But that cannot be factored anymore because 3 is not a perfect square. So this is actually your final answer. So that is factoring the sum or difference of two cubes and factoring by grouping. I know it looks like a lot, but these come with practice and recognizing these little tricks. So don't worry, we'll be practicing them plenty and you'll do perfectly fine.